Today we're going to talk about angles and circles. And how we are going to do the work is we're going to figure out where the angle's vertex is, and that will tell us what formula, because these are all formulas that we have to use. So, how do we find the measure of various angles associated with parts of a circle? Step one, we're going to determine the location of the vertex. Okay, now remember, the vertex is the corner of your angle where your two rays meet that make your angle. So that's your vertex right there. And I'll make it red just so we can all see it. So that is the vertex. So there are 4 different places your vertex can be. And then we have pictures that go with each, and then each one has its own formula. So if your vertex is at the center of your circle, to find the angle measure, okay, so there's actually 4 angles here. You can see them. I'm only going to highlight one. I'm going to highlight this one. Here's my vertex. If your vertex is at the center, your angle measure is equal to whatever its intercepted arc measures. So if we look at this angle here that I marked, that angle actually measures 90 degrees. So there's my box. So since my vertex is in the center, the angle is the same as the arc, so my arc is also 90. And remember, when we say arc, we are talking about this curved part of the circle. Okay, they call it the intercepted arc, but that arc is 90 because the central angle is 90. Now, if we look at the next picture, we can see that our vertex is actually on our circle. So here's my angle, and I go a little past the circle just so you can see its intercepted arc. Here's my vertex, it's on the circle. Here's the other side of my angle. So this one has a different formula. Okay, so let's say that arc right there is, well, let's make it red since I've been making the arcs red. Let's say that our arc, this intercepted arc, let's say that measures 80 degrees. Okay, we want to find what this angle measures. So our formula is our angle is going to be equal to, it's going to be the arc divided by 2. Oh, let me write that again. So if my arc is 80 in this picture, to find my angle measure, I take the arc and I divide it in half, and so I find out that my angle is 40. So if my vertex is on the circle, then I take arc and divide it by 2. Now, if we look at the next picture, okay, and there's, again, 4 different angles here, and we could find the measure of any of them. I'm just going to highlight this one right here. Again, we could find the other 3 if we wanted, but here's my vertex. If I look at that vertex, the only thing I can say about it is that it's inside my circle. It's not in the center. We already have a formula for that. It's not on the circle. My vertex is in the circle. Now, the one thing you do have to pay attention to this is when we talked about vertical angles, this angle right here and this angle right here would be equal because they're vertical. And so to find this, I'm actually going to trace this angle too, and you'll see why in a second. But to find either one of those angles I just marked in red, I need both of these arcs. I need this arc and I need this arc. To find the angle measure, the formula is you take the two arc measures and you divide by 2. You add the two arcs and divide by 2. So in other words, if I know that this arc right here on the bottom is 120 degrees, and I know that this arc right here is, let's say, 40 degrees, to come up with either angle measure, again, they're vertical, so they'll have the same measure. I take the first arc and I add it to the second arc and I divide it by 2. So 40 plus 120 is 160. 160 divided by 2 would give me a measurement of 80. So this angle in here would be 80 and the angle vertical would be 80. I'm not going to write it because I don't really have enough room. So arc plus arc divided by 2. The last picture, if you look, here's my angle. My vertex is right here. So if we look, our vertex is outside the circle. I also notice that with this angle, it intercepts two arcs. It intercepts this arc, which is what we call the small arc, and it intercepts this arc, which is clearly bigger. The formula to find this angle measure, okay, because again, we're finding angle measures. If we want to know what this angle right here measures, here is your formula. You take the bigger arc, and I just call it big arc, and you subtract the smaller arc. So you take your two arcs and subtract, big minus small, and you divide it by 2. So big minus small, that's how we say it. So if this arc out here is 70 degrees, okay, and we know the smaller arc up here is 20 degrees, and we want to know this angle measure, we take the big arc minus the little arc and divide it by 2. So 70 minus 20 is 50. 50 divided by 2 is 25. So this little angle, I'm going to draw an arrow, would measure 25 degrees. So what you want to do is just make sure you know your formulas. If your vertex is at the center, your angle equals your arc. If your vertex is on, your angle is arc divided by 2. If your vertex is in the circle, it's arc plus arc divided by 2. And if your vertex is outside the circle, it's big arc minus small arc divided by 2. So let's look at some examples. So let's look at number 1. Okay. Number 1 says, find the measure of angle 1. Okay. So first thing I'm going to do is I'm going to come and I'm going to mark angle 1. That's angle 1. And I'm going to trace it, because I have to decide where my vertex is. So I trace angle 1. And my vertex is right here. So where is my vertex? Center, in, on, or out. If you look, your vertex is just inside. It's definitely not in the center. Okay, so your vertex is in your circle. Our formula for in is arc plus arc divided by 2. So what I have to do, remember this is the one you have to use the vertical angles. So the angle that's vertical to angle 1 is this angle right here. So then I also want to trace this angle so that I can see the two arcs that I'm working with. So the two arcs that I'm working with are this one, okay, because it's intercepted by angle 1, and this one, because it's the vertical angle that intercepts that arc. So you do need to show your work on this. You cannot just have answers. So how would we set this up? We would say 70 plus 60 divided by 2. So that's 130 divided by 2. So angle 1 is 65 degrees. So I know this angle is 65. If they asked us this angle over here, we could also write 65. And we actually, using old stuff, if they needed it, could figure out this angle here and here if they really wanted to know. We're not going to do that, but we do know how to find that. So angle 1 is 65. Arc plus arc divided by 2. So let's look at number 2. I'm going to check out and see what they want me to find. They want me to find the measure of angle 1 and the measure of angle 2. And there's 2 ways that you can do this. But we're first going to do angle 1. So I'm going to find angle 1. Here it is. And I'm going to trace it. So when I trace it, there's angle 1. So I'm going to figure out where my vertex is. So where is my vertex? My vertex on this one is on the circle. Okay. My formula for on is just arc divided by 2. So I look at my angle, I find the arc it intercepted, which would be this. Okay. I see that it's 120. So to find angle 1, I take 120 and divide it by 2. Arc divided by 2. So I find out that angle 1 is 60 degrees. 120 divided by 2 is 60. And I would come over to my picture and I'd put that in my picture. So angle 1 is 60 degrees. Now, 2 ways you can find angle 2. You should know something. Well, I'm going to show you with the circle first. Then we'll talk about the other thing. We know an entire circle is 360. If what I marked in red is 120, and I'm looking now for angle 2, so let's make angle 2 green. So here's angle 2. Okay, I see that my vertex still on my circle, so my formula is still going to be arc divided by 2. I look at my picture, okay, and I realize this is the arc that I need, but I don't have a number on it. Okay, and so some people think, oh, I can't do this, but you actually can. Because what do we know a whole circle is? A whole circle measures how many degrees? A whole circle is 360 degrees. So I have 360 degrees. I know that this arc over here, that's red, I know that arc is 120. So if I want to know what I have left for angle 2, or sorry, for the rest of the circle, then I'm going to say minus 120. Okay, and that tells me I have 240 degrees for the rest of that piece of the circle. So now I can actually figure out angle 2, because to find angle 2, again, I figured out my vertex is on the circle, which means I need to do arc divided by 2. To do arc divided by 2, I needed that arc measure. I just figured it out. It was 240. So I'm just going to say 240 divided by 2. And that gives me 120 degrees. So angle 2 is 120 degrees. Now, there's actually another way that you could have found angle 2. I'm not going to show it to you just because I don't want to confuse anybody. But if you see it and you want to do it that way, as long as you can explain it to us, you're welcome to. If you don't see it, don't worry about it. Use your formula, arc divided by 2, and you'll be able to get angle 2. All right, so let's look at number 3. So again, first thing I do is figure out the angle I'm looking for. Angle 1 is right here. Okay, they want the measure of angle 1. That's what it says. So I'm going to mark it, and then I'm going to trace it so I can see exactly what I'm working with. So there's my angle. So now I have to decide, where is my vertex? My vertex is this point right here. My vertex is outside my circle. Okay, and what you want to kind of run through your head is center in, on, or out. It's outside. If it's outside my circle, my formula says big arc, I'm just going to put big, minus small arc divided by 2. Okay, so I trace my angles. I'm going to mark my arcs. So here's one of the arcs that's intercepted. Here's the other arc. I have numbers on both, so I don't have to do anything to figure that out. So I'm just going to plug them into my formula. My formula says big arc minus small arc. So my big arc is 150 minus my small arc is 50. And the formula says divide by 2. So angle 1 is going to be 150 minus 50 divided by 2. So 100 divided by 2. So angle 1 ends up being 50 degrees. Now, that's just coincidence that it matches the small arc. Don't try to take a shortcut and think it's always going to be what the small arc is. It's not. But this angle right here is 50 degrees. Big minus small divided by 2. All right, so I want you to pause the video, see if you can set up 4, 5, and 6, work them out. Once you think you've got them, come back, check your answers with the video, and make sure you've got it. I'm just going to keep going, but pause the video. I want you to work 4, 5, and 6 out by yourself, then come back and check. Make sure that you did it correctly. All right, number 4, they want angle 1 and angle 2, so this looks very similar to number 2. So I'm going to, here's angle 1. I'm going to trace my angle. Okay, for angle 1, my vertex is on. It's on my circle. So my formula for on is arc divided by 2. So I look at angle 1. I find my intercepted arc, which is this right here. They tell me it's 60. So my formula says arc divided by 2. So my arc is 60 divided by 2. My angle turns out to be 30 degrees. So angle 1 is 30 degrees. Now, they also want angle 2. So I'm going to come over here. Here's angle 2. I'm going to trace angle 2 so I can see what I'm looking at. So here's angle 2. My vertex, again, is on. So I need to use this formula, arc divided by 2. But I notice I don't have anything on my intercepted arc. There's no number. Okay, so just like we did in number 2, I have a way of getting it. I know the whole circle is 360. I know part of it is already 60 degrees. I don't want that part. So I subtract. That leaves me with 300 degrees for this part of the circle that's blue. So angle 2, arc divided by 2. Figured out my arc was 300 divided by 2. So angle 2 ends up measuring 150 degrees. Number 5, again, looking for angle 1 and angle 2. So I'm going to trace angle 1, see where I'm at. I look, my vertex is in. My formula for in is arc plus arc divided by 2. Okay, so remember, this is where you have to use your vertical angles. So I need this arc that's intercepted by angle 1, but I also need to look at the vertical angle, which would be this one right here, and that intercepts this arc. So if my formula is arc plus arc divided by 2, then I say 40 plus 200. You could also say 200 plus 40 divided by 2. Do the math, and I find that angle 1 is 120. Okay, so this angle right here measures 120 degrees. Now, watch what happens when we go after angle 2. Okay, if I look at where angle 2 is, I trace it. My vertex is still in, so that means I know I have to do arc plus arc divided by 2. That means I have to use its vertical angle. So the two arcs that I need to use are this one, which has no information on it, and this one. Okay. Now, we could use what we know about a circle, but I'm actually going to go back and use something old that we've done over and over again. I'm going to use linear angles because it's actually on this problem, it's faster. So remember, linear angles are next to each other and make a straight line or a straight angle. So if we look, let me change colors. If we look at angle 2, there's angle 2. It's next to or adjacent to angle 1, and they make this straight angle. Okay. Remember, straight angles measure how many degrees? 180. So to get angle 2, if I know angle 1 is 120, all I would have to do is subtract using linear, something we learned like the second week of school, and that tells me angle 2 is 60. So I didn't even have to use a formula, and I really couldn't use this formula because I don't have any number on this arc, and I don't have any number on this arc. So I couldn't do arc plus arc divided by 2. Okay. So I actually had to use the linear pair. All right, last one of these examples. Again, I'm going to trace my angle so I can see where my vertex is. So I trace. My vertex is right here. My vertex is outside the circle. Okay. That tells me the formula that I need to use is big arc minus little or small arc divided by 2. So be careful on this one. You have to pay attention. I look and go, okay, there's my big arc. There's my big intercepted arc. The other arc I want to use for small, it has to be the intercepted, is this one. It is not the 130. Okay, the 130 degrees is just how much of the circle is right here, and that is not the arc I need. Okay, it has to be the intercepted arc. So we're going to have to figure out what that missing little piece actually is before, what this piece is right here, before we can even use our formula. So we have to go back to what we know about the entire circle. The entire circle is 360 degrees. Okay. I know that the red part of the circle is 190, and I know the green part of the circle is 130. So all I have to do is add those two together. So that would be, 320, and subtract it from what the whole circle is. And that will tell me what I have left for this little blue piece that I need. So 360 minus 320 is 40. Now I have my big arc, which is 190. That's what's marked in red. Minus, what's my small intercepted arc? We just figured it out, it was 40. So big minus small divided by 2. You just have to be careful because we see a lot of people that want to do 190 minus 130 divided by 2, and that actually is incorrect because 130 is not the intercepted arc. Okay, it's just outside the angle. It's a part of your circle. So we do that, 190 minus 40 divided by 2. We find out that angle 1 is 75 degrees. So this angle right here measures 75 degrees. All right, so just make sure you go back. Make sure you can figure out center on in outside, and then that will direct you to the formula that you want to use.